Okay, let's have a look at part B of this question now. In part B, we're given the line TU. And we're told that we're dealing with centimetres here. And we're asked to use what we did in A part 2 in order to construct a line segment equal in length to the square root of TU. Okay, so now you really need to focus on what we did in A part 2. So let's just talk about our diagram from A part 2. In A part 2, we had the line AB, which had a length of x. And what we did was we went 1 centimetre further. So we had AB and then we continued on 1 centimetre further. And then from A to 1 centimetre past B, that was the diameter of our circle. If once we drew a semicircle, if you go up from B, the distance from B to the circle is equal to the square root of AB. So the distance from B to the circle, the perpendicular line here, is equal to the square root of AB. In the line we've been given TU. The TU in this line we need to treat it the same way as AB. So what AB is in this diagram, TU is in the diagram for part B. So let me just talk you through what we're going to do and then we'll do it accurately. Once you see the word construct, it means you actually need to carry out one of your constructions. I want to just basically replicate this diagram. I have TU, which is synonymous or the same as AB. So what I'm going to do, in order to measure a length that is the square root of TU, the first thing I need to do is I'm going to continue this on 1 centimetre. We're going to measure 1 centimetre. You can't simply just measure TU with a ruler and then measure the square root of it because it asked us to construct it. So we're going to take TU, we're going to add on 1 centimetre to it. And then I want you to just visualise, we'll talk about how we'll do this in a moment, but if we can accurately work out the centre of this line, we're going to construct a semicircle, and if we draw a line perpendicularly up, the distance from U to here will be the square root of TU. Now I'm only roughly doing it, but basically that's what we're going to do. The first thing we do is continue it on 1 centimetre, work out the centre of this line, draw our semicircle, and then draw a perpendicular line. If we can do all of that accurately, then the distance from U to here will be equal to the square root of TU. Just like in the diagram from A part 2, the distance from B to here is equal to the square root of A to B. So let's talk about this in detail now. So now that we've discussed what we need to do, we have to actually carry it out. We've been given the line TU. What I need to do is just imitate what the situation was in A part 2. First thing we're going to do is use our ruler and simply measure 1 centimetre further on and mark it in. So once you've measured 1 centimetre, you simply continue it on. If this is U, then the end of the line is 1 centimetre further on. Obviously my dimensions are actually larger because if I only went 1 centimetre, you wouldn't even be able to see it on the board. But on your page, you continue on 1 centimetre. What I want to do now is I want to draw a semicircle. So obviously I'm going to need to use my compass and place my compass at the very midpoint of the line and draw my semicircle. But I have to obviously figure out where the midpoint is. This is where the construction comes into play. You should recall the construction number 2. In construction number 2 at Leaving Cert Higher Level, we construct a perpendicular bisector of a line. It's a line that's perpendicular to the given line, but more importantly, it's a bisector. Bisect means it cuts it in half or it goes through the midpoint. So you should refer to your notes to what we carried out in construction number 2. Let's talk about it here. In order to construct a perpendicular bisector of a given line, the first thing you need to do is place your compass at one end of the line. Place the pin of your compass at one end of the line and measure a radius that is roughly 2/3 of the way from T to the end of the line. Just roughly 2/3 of the way from T to the end of the line. If you keep your compass here, the pin of your compass here, use your pen and draw yourself an arc. So that's what I'm going to do now. So I place the pin of my compass here, measure the radius that is roughly 2/3 of the way from T to the end of the line, and I've drawn an arc. It only needs to be roughly 2/3 of the way. It's the next bit that has to be 100% accurate. Now I'm going to draw another arc. I'm going to place my compass at the other end of the line. I need to keep my radius length exactly the same. So the distance from T to this arc is going to be exactly the same as the distance from here to my new arc. Okay, so now I've drawn my second arc, and this is going to allow me to construct a perpendicular bisector. If I draw a straight line from the point of intersection of the arcs at the top to the point of intersection of the arcs at the bottom, if I draw that line, it will be a perpendicular bisector. And importantly, the key here is if it's a bisector, it's going to go through the midpoint of the black line segment. So I've used my ruler here and I've drawn my blue line. The blue line is a perpendicular bisector of the black line. Now at this stage, you're probably trying to remember why we're doing all of this. Remember, the question was to construct a line segment that is equal in length to the square root of the distance from T to U. I know from A part 2 that if you have a line and you continue it on 1 centimetre, draw yourself a semicircle. If you draw a line straight up from U, the distance from U to the edge of the circle, the distance I'm going to get here, will be the square root of TU. So obviously the point here is I need to draw a semicircle. You can't construct a semicircle unless you know the centre of the circle. The point of intersection of the perpendicular bisector and the black line segment, that's the midpoint. This point here is the midpoint of the black line. And obviously the distance from T to here is the diameter of the semicircle I'm about to draw. So what I need to do now is one more time use my compass. Place my compass at this point, and I'm going to measure a radius from the blue dot here to the edge of the black line, and I'm simply going to draw myself an arc that will end up back at the point T, and that will be my semicircle. So I placed my compass at the blue point, and I measured a radius from the blue point to the edge of the line, and I've drawn myself a semicircle. In A part 2, I deduced that if the distance TU, if this was x, then the distance from the point B to the edge of the circle was the square root of x. We called it y at the time, but we deduced that y was equal to the square root of x. Or in other words, the distance from U, if I go perpendicularly up to the edge of the circle, that distance is equivalent to the square root of the distance from T to U. So in order to get the full marks here, I simply need to draw a line, a perpendicular line that goes through U. When carrying out constructions, it's really straightforward to draw a perpendicular line. We have a number of rulers in our math set that have 90-degree angles. So I simply need to line this ruler up with the base of my diameter. So if I line this up with my diameter, I simply draw a line from U and I go straight up, and that's going to give me my perpendicular line from U to the edge of the circle. So you'll notice here I've used my set square and I've drawn a line perpendicular to the diameter, goes straight up from U. Now in order to verify that you're actually accurate, you could now actually measure the distances. If you measure the distance from T to U and then measure the distance from U to here, whatever this is, it should be the square root of whatever TU is. So if the distance from T to U is 9 centimetres, the distance from U to here should be the square root of 9 centimetres, which is 3.